Why not? Hey, I ain't gonna staple, bro.
Guys, I am starting to record, which means you need to stop talking and we need to move on. You are wasting too much time. Okay. Every function has what we call a parent function. This is before anything has happened to it, before we've moved it up, before we've shifted right, before we've made it larger or shrink it. Okay, it's called your parent function. So, a linear function. Your parent function looks something like this.
Chicken with a waffle on it.
Chicken with a waffle on it.
Good.
Okay, so you did linear functions in Math 1. A linear parent function looks like this. Y equals X. Okay. Why are we continuing to talk? Okay. So your linear parent function looks like this. Y equals X. Earlier in this year, we talked about quadratics. And your quadratic parent function was y equals x squared. That's how we knew it was a quadratic. Okay? We have a parent function that is a radical. CJ, you are about to leave this classroom if you cannot stop talking.
I'm about to go ahead and tell you straight up. I ain't did nothing right now, so we got your lesson, please.
Stop talking.
You just said
Stop
just got
talking.
your whole lesson talking to me, so
Stop
stop right
talking.
back around and get back on the board.
Right. That was just uncomfortable.
And I'm finna walk right out.
No, you're not.
Why?
Stefan gonna steal you.
If you do,
Miss Curry, can I have CJ Clark removed from my room? He will not stop talking while I'm trying to teach him new things.
Miss Curry, I was
Yes.
not talking.
Thank you. Okay, you have a radical parent function that looks like this. Y equals just the square root of x. Okay, so everything is going to be manipulated. Does anybody else need to say?
That one's tweaking. I'm letting you know that
That
right
one's tweaking.
now.
So, y equals the square root of x is your parent function. Okay, the easiest way to draw any type of graph is to create yourself an XY table. So, what we do is we pick values for x that's going to come out and give us a y value so we can plot them. Okay, so we're dealing with square root. So, x equals 0. When I plug in 0, what is the square root of 0? 0. So, your first point that we can plot is 0, 0. That goes here. Okay, there's your first point at the origin. Oh my. Okay. CJ.
Come on, man.
Okay. Now, remember, we're dealing with square roots, so you want to pick values of x that we can take the square root of. So, something like x equals 1. What's the square root of 1? 1. So, there's my second point at 1, 1. Oh, why is this light keep doing that?
It's going out.
It's been doing this since last year, and they haven't changed the light bulb. It randomly picks days to do it.
You said Miss Kirby watching over, right? She should get the message by now. Can't even teach.
Okay. So, can I take the square root of 2 and get a whole number?
Mm-hmm.
No. So let's skip 2. Can I take the square root of 3 and get a whole number?
No.
No. What can I take the square root of next? 4. So, when x is 4, what's the square root of 4? Square root.
Square root.
2. Okay. So, I have a point at 4, 2. What's the next number that I can take the square root of?
No, 9.
9.
9, child.
I can take the square root of 9, and the square root of 9 is 3. 6, 7, 8, 9. 1, 2, 3. So I have a point here. Okay, so your graph of your parent function looks like this.
I can like disable.
Okay. They call this the wing. Okay, because it looks like a bird wing coming out.
Yeah, it does.
Okay. So they call radical functions the wing.
Yo, I am blank.
You are what? Okay. If you flip the page,
No. Go back.
oh boy.
Bro.
Okay. This time I've changed my equation. What's different about this one? There's a 3 in the front. So what do you think that's going to do to my equation?
Make it look weird.
Make it look weird.
Yeah. What's I say?
Make it look weird.
Opposite.
Anybody else have an idea what your graph's going to do?
It's gonna look weird. That's all I can say.
It's not going to necessarily start at 3.
It's gonna go
per se.
all the way
Yeah, I need
to.
Your graph, listen, your graph is going to blow up taller. Okay.
I just said
So watch what happens. So if I plug in 0, just like we did on the last one, you get 3 times the square root of x. Well, my x value is a 0. So what's 3 times the square root of 0? 0. Square root of 0 is 0, and 0 times 3 is 0. So my graph starts off in the same exact spot, 0, 0. Okay? The next number we plugged in was a 1. So it's 3 times the square root of 1. Okay? What's the square root of 1? 1, and 1 times 3 is? 3. So here's where it starts to change. Instead of having a point at 1, 1, we have 1, 3. The next number we plugged in was a 4. So what's 3 square roots of 4? What's the square root of 4? 2, and 2 times 3 is 6. So we've got a point at 4, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay. We can still do the next one. We're just not going to have room on the graph to draw it. Yes. Do I have toilet tissue?
Do you have tissue paper?
Are we out of Kleenex?
I'll be on the block on the regular.
Okay. What happens when I plug in 9?
Okay, you got to do the square root of 9, which is 3, and then you got to multiply 3 times 3, which is 9.
Good. The square root of 9 is 3, and then we have to multiply that times 3, and we get 9. Yeah. Okay. There's just not enough room on this graph. So, my graph now looks like this.
Bro.
Okay.
I told you look weird.
So, we went from this graph that kind of like leveled off here, and we made it like this big hunch. I always think about like the Hunchback of Notre Dame. Okay. It's got a big hunch now. It has blown up vertically.
That's how my ball. My life is a ball. That's how it looks.
What if my A value wasn't a 3? What if it was a 1/2?
Oh.
Instead of it blowing up, what do you think it's going to do?
You
Go down.
So instead of blowing it up because it's a big number like 3, what if I gave it 1/2?
It's gonna go down.
It's going to shrink down, okay? Your graph's going to look like this skinny little line towards the bottom,
You will.
okay? All right. If you flip the page, the next one. So not only is there a 2 out there, which makes it blow up vertically, it's got a -2. So instead of it being an upward swing, we're now going to flip it. This negative flips it. Okay, so again, let's stick with our same number. If x is 0, Stefan, focus.
Focus, Pootie.
If x is 0, we've got -2 square roots of 0,
Which is 0.
which is 0. Okay, so this one still starts out in the same spot, 0, 0. We didn't shift left, we didn't shift right, we didn't shift up or down. Okay, the next number we plugged in was a 1. What's -2 times the square root of 1? -2. Okay. The next number we plugged in was a 4. So -2 times the square root of 4. What's the square root of 4? 2. 2 times -2 is -4.
Negative 5.
-5.
Yeah.
Okay, the last one we plugged in was a 9. So -2 times the square root of 9.
-6.
-6.
-6. That downward slope.
Okay, so that negative has now taken your graph and it's flipped it upside down. Okay, it did the same thing with a quadratic. If we had x squared, it was an upward facing u. If we made it -x squared, it threw it downwards and we had that downward facing u, where you had a maximum instead of a minimum. So the negative does the same thing, whether it be an absolute value function, radical, quadratic, linear. It takes your graph and it flips it in the opposite direction. So this will not change when you move on to Math 3 with either Mr. Estrada or I think Miss White might be teaching it next year. I'm not quite sure how it's all going to fall in place. But when you get to absolute value, all of your rules are the same. If it's a negative, it flips your graph upside down. Okay, 2 more. What happens when I add or subtract outside of the square root? Okay.
That's what we're doing. Oh, Jesus. Oh, Jesus Christ.
Hey, calm down. Calm down. Okay. Whenever we add or subtract a number on the outside, it's not with your x. So what should this affect? If it's not inside with your x, it's going to affect what other variable? Your y. Okay, so if it's +4, everything should go up by 4. And if it would be a negative number, everything shifts down. Outside of the square root affects your y value. So again, let's start with 0. We always start with 0. So the square root of 0 plus 4 gives me what? 4. Okay. Square root of 0 plus 4 is 4. Normally we started at 0, 0. Now we're going to start up 4. Okay. Then I've got 1. The square root of 1 plus 4. 5.
2.
We plugged in 4. Remember, we're trying to pick numbers that are going to give us evens. So the square root of 4 plus 4. 6. Okay.
Then we're going to go to 6. 9.
9. So the square root of 9
Give us
plus 4 gives me 7. So we have a point at 0, 4, 1, 5, 4, comma 6, and that's all we're going to be able to graph because there's not a 7. Is there 1, 2, 3, 4, 5, 6? Yep, I counted wrong. Whoops. 6. Four, 5, 6, 7, 8, 9. There we go. Okay. So we're back to our regular graph. Everything has just been shifted up by 4 because we added 4 onto your equation.
What is this?
Ignore my mess up there at the top.
Of course you will.
Of course you will. You're so sweet.
Ooh, girl. Ooh,
Okay. The last transformation that we need to talk about is what happens when I add or subtract something on the inside with my x. So if I have x minus 3, which way do you think that's going to shift my graph?
About
It's with your x, so it's going to move something in your x direction.
left.
Wrong.
Up. Yep. See, that's why I don't.
Remember, listen, and think about it because we did this with quadratics. When it was x minus 2 squared, remember the minus 2 moved it in the right. It's always the opposite with when you're in the x. So if we have x minus 3, everything should be shifted to the right. Okay? It's always opposite. So this shifts to the right. If you want to make note of that, that shifts it to the right. It's always opposite when it's inside with the x. Okay, so this one's going to be slightly difficult because we've got to figure out ways to get x values that I can take the square root of that number. So what can I plug in for x here to give me a y value of 0? What can I plug in so this becomes the square root of 0? A 3. I can plug in a 3 for x, and my output is a 0 for y. Because watch what happens. You get the square root of 3 minus 3, which is the square root of 0. Okay, I want an outcome of 1. What x value can I get to make this be a 1 underneath the square root? 4. So x is 4, which means I've got the square root of 4 minus 3, which is the square root of 1. I want a y value of 2, which means I need to make this underneath the square root a 4. What can I plug in for x? Subtract 3, that's going to give me 4. What minus 3 gives me 4? 7.
What?
The square root of 7 minus 3 gives me the square root of 4, which is 2. Okay, one more. I want the underneath to equal a 9. So I get the square root of 9, which is 3. So what minus 3 is going to give me 9? 12. Fantastic. So the square root of 12 minus 3 is 9. Okay, go ahead and graph those. So 3, comma 0, 4, comma 1, 6, 7, comma 2. That's going to be the last one you're going to be able to graph. Okay. So all that happened to your picture is it used to start at your origin, and now it just starts 3 to the right. That's all that has changed. Okay, every one of your points has now been shifted to the right. Okay, Before you close that up, go back to example 1. We need to talk domain and range. Okay, domain. Think of this point as your starting point, okay? Always. Think of this point as your starting point. What is your X value at that point? So this is your starting point. What's your X value? 0. Okay, so you've got X and 0. Is your graph then going to the right or to the left? To the right. So this is X is greater than or equal to 0. That's your domain. Because it's either 0 or bigger, because it's going to the right. Okay, for the range, you're going to do the same thing. Remember, range is your Y values. What is your Y value at this point? 0. And is it going up or down? Up. So is it greater than or less than? Greater than. So it's greater than or equal to 0.
Hold on.
Okay, so always pick that starting point, find your X value and your Y value, and then give me your signs. If it's going to the left, it's less than. If it's going to the right, it's greater than. If it's going up, it's greater than. If it's going down, it's less than. So go to your next graph. Domain and range. Domain is your X value, range is your Y. My starting point is here. What is my X value? 0. Okay. Is my graph going to the left or to the right? Right, which means it's greater than. Fantastic. Greater than or equal to. What is my Y value at this point? 0. And am I going up or down? Down. So this is less than or equal to 0.
Hold on.
See, domain and range isn't too bad, right?
Yes, it is. I hate that.
I actually enjoy it with radicals. I think it's a lot easier with radicals than anything else. Okay, flip to the next page. Domain is your X, range is your Y. Okay. Again, find your starting point, which is here. What is my X value here? 0. And is it going left or right? Right. So it's greater than. What is my Y value here? 4. And is it going up or down? Up. So greater than. Okay. See how your Y value changed to a 4 this time? Okay, because your graph's been shifted up. Okay, last one. So, my X value at my starting point is what? 3? Greater than or less than? Greater than. My Y value is a 0. Greater than or less than? Greater than. Fantastic. Does anybody have any last minute questions on graphing or what the graph of a radical will look like? No.
Thank